All right, let's take a look at a couple of these problems together. Oftentimes these problems, even though they're really simple, will trip up students. And the reason for that is because of the rounding and the rules for significant figures. So let's take a quick look. Here we've got a simple equation, volume equals length times width times height. We're given the length, we're given the width, and we're given the height. And so all we have to do is multiply those things together. Now, if you do that, I'm just going to do that over in Google on the other window here. You will get a number that is 4,000. Let's see here. Sorry, let's just write it down. 4,418.82. And if you type that in, you will be marked wrong. And the reason for that is because each of these values has three significant figures, right? Each of them has three sig figs, but this answer has more than that, right? So we really should round our answer here to three sig figs if we're following the rules. In this case, that means we should be rounding it to, I'll put the answer down here, 4,420. Now, in fact, I shouldn't even technically put that little dot there if I'm following the rules carefully, right? Because there's only three sig figs, 4, 4, and 2. Now, you might be like, well, that doesn't make any sense because, look, I type it into a calculator and I get this number up here. You know, this is the exact answer. Why would I make my answer wrong, inexact? Well, the reason for that is because we're used to working math in math class. And in math class, when you're given a number, you are expecting that number to be exact. So in other words, this 16.7 here, when we think about that 16.7 in a math class, it would actually be exactly 16.7. 16.70000 forever, right? It's exactly 16.7. But we're in a physics class, and in physics, these numbers are not hypothetical, they are measurements. And measurements, as we've learned, have intrinsic uncertainty. And so what this means is that this value has been measured, and the closest I can get is 16.7. But the true value could be 16.70, but it could also be maybe 16.74821. Maybe that's what the actual value is, right? Or maybe this is just the closest I could get with my ruler, you know, to the nearest tenth of a meter. And so it could be that the actual value is 16.65. Now, if you were to actually try this calculation with different values, like 16.65 times 10.45 times 25.15, you would find that this answer is not the same, right? It changes because these values may vary slightly. Okay, so the point is, the reason we have to round our final answer is so that the precision that we give in our final answer matches the precision of the rounded values. Let me give you just one little example of that, just to illustrate why this matters. So let's just say, for example, I'm just going to erase this to have more white space. Let's just say, for example, I tell someone, hey, you know what? I can walk 1 mile in about 3 minutes. Okay? I can walk 1 mile in 3 minutes. Okay? Wow, that was thunder. I don't know if you can hear that or not. I could walk 1 mile in 3 minutes. Well, then they're like, oh, well, that's cool. That means you can walk 1 divided by 3 equals 0.33333333 miles per minute. So that's your speed, right? And of course, I could add a lot more threes here. Now, it just happens to be a trick of math that this 1 divided by 3 goes on forever, right? That does not mean that I know to the 10 millionth of a mile my exact speed, right? This has to be rounded to the same number of sig figs as my provided measurements. And in this case, those measurements were not very accurate. It just said 1. It wasn't 1.0 miles or 3.00 minutes. You know what I'm saying? Okay, so let's take a quick look at just one more of these so you can see what we're up against here. Sorry, I got to erase this. Okay, because this can certainly be very frustrating, and I don't want you to get frustrated as you're doing these. We'll also be rounding according to sig-figs throughout our course. And getting used to these rules now is going to save a lot of frustration later. So let's take a peek at, this one's usually less of an issue. This is a reasonable one because it involves pi. So again, in math, we're accustomed to dealing with like ultra precise values. Now here you're like, okay, well, pi has lots and lots of significant figures, right? Because we know it goes on forever. So how many digits do I need to use? And then how do I round? Well, when we're dealing with a value like this, like a constant, that does not figure into our significant figure calculation. So in other words, we don't care how many sig-figs pi has. We're only interested in our measurement, okay? Now, you would want to use at least 3.14. You could also just do 3.1415, or you can use pi in your calculator. It won't matter because we're going to round our answer according to sig-figs. So here I have pi times diameter, and I'm given the circumference. So I want to take the circumference, 495, divided by pi. Okay, in this case, if I just type that into a calculator, 495 divided by pi, I'm going to use the exact value. It's going to give me, of course, a really huge number, right? And that poses a challenge for us of like, well, how do I round it? So 157.56 339, and it can be tempting to be like, well, I need all these digits. Well, definitely not, because we only have 3 sig-figs. It's 495 feet. And so our answer should be rounded to 3 sig-figs as well. In this case, that means 158 feet. Now imagine if you actually did provide all of the digits that your calculator did. I mean, this is how many mine gives. This is implying, now this is in feet, right? So this is a tenth, a hundredth, a thousandth, 10,000th, 100,000th, millionth, 10 millionth, 100 millionth, a billionth. When you provide all those digits, you're implying that, oh yes, I know the diameter of this circle to a billionth of a foot. That's like higher precision than like the most precise measurements ever recorded, right? And all they did was tell you that it was 495 feet. So if you think about it, I mean, well, I understand why it makes, like, it's frustrating or it doesn't make sense to round it, but really it makes even less sense to give all of these digits of precision. That's why we use the rules of significant figures. Okay, you can review those at the end of chapter 1. Review them if you are finding you're getting some of these questions wrong, because chances are that's the reason why.